In this video, you'll learn how to justify the solutions to your equations by naming the property used in each step. This will cover New York State Next Generation Learning Standard 1A in the Algebra 1, Reasoning with Equations and Inequalities. The goal is to understand solving equations as a process of reasoning and explain that reasoning. By explaining each step when solving a linear or quadratic equation as following from the equality of numbers asserted at the previous step, starting from the assumption that the original equation has a solution. You will construct a viable argument to justify a solution method. By the end of this tutorial, you should be able to say that you can justify the solution to an equation by naming the properties used in each step. These are some of the properties that you'll be using today. Not all of them, but these are the most common. So let's take a look at our first example. The original equation 3x plus 5 equals negative 13 is what we were given. So the first thing we write is that is the given statement. Now I'm choosing to show my work here vertically. However, it's very common for the work to be shown horizontally. So I'm going to move my screen back and forth for a second for you to see that difference. Same exact problem, but work shown horizontally as opposed to vertically here. You see that minus 5 on each side? This is horizontally, this is shown vertically. But the math is the same and the properties are the same. So it doesn't matter which way you write your work or which way you see the work shown for you. Since this is the most common method for students to write their own work, right? We'll talk about these steps here. So the fact that I subtracted 5 from both the left and the right side equally and fairly, that's called a property of equality. Anytime you perform an operation both to the left and right side, that is a property of equality. Now technically, there's only addition property of equality. There's really no subtraction property of equality. What you're really doing is adding a negative value. But I'm going to allow you to use this phrase today, just for the sake of your understanding. So I'm subtracting 5 from both sides. That's called a subtraction property of equality. That leaves me with this statement here. 3x equals negative 18. So the question is, how did I get from my given statement to this statement? What disappeared and what happened to it? Well, since the 5 disappeared from both the left side and combined on the right side, we call this an additive inverse, because technically these two 5s make a 0. I'm just being a little bit lazy and not writing the 0. But when that happens, and you cross some terms out because they make a 0, you have to write that. So that's the additive inverse property. Every time you write the phrase property of equality, an inverse property must be written after it. Every time you use a property of equality, an inverse property must be written after it. So my next step is division on both the left and the right sides by 3. So I can divide by any number I want, but the fact that I'm dividing both sides is the division property of equality. Again, just like the subtraction property of equality, there is really no division property of equality. Technically, I'm multiplying both sides by 1/3. So I would write the multiplication property of equality here. But typically, when the coefficient is an integer, students use division. So I'm going to allow you to use the phrase division property of equality here, even though it technically doesn't exist. So our final solution is that x is equal to negative 6. But we have to state what happened here. The fact that 3 divided by 3 is 1, that's called a multiplicative inverse. I'm not writing a 1, but I could. If I wrote this step here, and I decided to leave the 1 off in the next line, that would be called an identity property, where this and this item were the same, right? Same identity here. Again, the steps are the same, whether my properties of equality are written horizontally or vertically. So let's take a look at another example. Remember, anytime you use an inverse property, the next step must be either the additive or multiplicative inverse property. So 2x plus 8 equals 20. So the first thing we write next to this is that this is given. Then we start showing our math. I'm going to abbreviate here. This is kind of like a word bank, right? Those are our most popular properties, and those are the ones you'll typically be choosing from. The fact that these two 8s cancel out and become a 0 is the additive inverse. Remember what I said? Every time you write a property of equality, the next line has to be an inverse. Alright, I'm going to divide both sides now by 2. That's the division property of equality. And remember what comes after a property of equality? Some type of inverse. Now, if the two items were adding together to create a 0, that would be the additive inverse. But if two items cancel out and reduce down to 1, that's known as the multiplicative inverse. So again, I'm abbreviating here, but these are the properties. Alright, let's try another one. Again, the first thing you typically write is that this is your given statement. So I'm going to go ahead and do all the math here, and then we'll fill in the properties. Alright, let's see if we can choose from our bank of properties over here on the right. So in this one, I actually had some parentheses on the first line, but I don't on the second. So that's the distributive property. The next one is my addition property of equality. And remember, anytime you use a property of equality, the line underneath has to be an inverse property. So the fact that 12 and negative 12 make 0, that's called the additive inverse property. I'm dividing both sides by 6, so we can call that the division property of equality. And remember, now I need an inverse property. So that's it. That's how you solve an equation and justify each step by naming a property. Here's some more examples for you to look at that are already solved. So this one uses the same properties over and over again. Again, the first line is given, so you would write or type given next to that statement. The next one is a simplification by using the distributive property. Then we use the subtraction property of equality, and now I need an inverse. Because I was adding or subtracting, this is the additive inverse property. Now here, I'm adding something to the left and right side, but this is a repeat, right? Anytime you add or subtract, the next one has to be an inverse property. So I'm going to duplicate that property I already used. And now I'm going to divide both sides by 7 and end with my multiplicative inverse property. Let's take a look at this one. Notice that in this example, after I distributed, I had some terms that were alike, 3x and 5x. But technically, when you're following the order of operations, you would have to subtract these before you can add those, right? So if we use the commutative property of addition, we can rearrange the order of our terms, allowing us to combine these two together. Now this is another spot where it gets a little bit tricky. When students combine 3x and 5x to make an 8x, a lot of times they'll write combining like terms. But technically, that's not a property. Now it's pretty sophisticated what's actually going on here. There is a distributive property that's happening here, which is why you're allowed to add the 3 and the 5x. But since you're not showing it as a distributive property, I'm going to allow you to use the substitution property, which means that you're stating that I'm going to substitute this expression here for that expression there. But technically, this right here can be factored out as x times 3 plus 5. And that's how I get x times 8, and that is how I get 8x. So technically this is really a distributive property. But if you're not writing it that way, then we're not going to justify it that way. So remember, if you're combining like terms, we're going to call that the substitution property. In the very next line, I added 6 to both sides. That's a property of equality. And the fact that the 6 is canceled out, that's an inverse property. So don't forget, every time you have a property of equality, the next line needs to be an inverse property. All right. I think you're starting to get the hang of this. Let's see if we can pull out from our bank of properties here to justify this last problem. So the first line is always our given statement. Looks like I'm distributed on both sides, so I'm going to pull down distributive property. Looks like nothing on my left-hand side changed, but the order of the items on my right-hand side changed, and that's called the commutative property of addition. Now under there, the 5m and the minus 3m became a 2m, so we're going to call that the substitution property, and the same thing happened on the left. 21 and the 9 became a 30. Then I have the subtraction property of equality here, and followed by the additive inverse, because these items over here, right, make a 0. In the next line again, I have the subtraction property of equality, and followed by the additive inverse, division property of equality, followed by the multiplicative inverse. This problem I did earlier, but you could certainly pause the video and try it on your own again. There are some problems in your notes that I'd like for you to try now. Pause the video after each one and check your solutions. Here are the solutions. Pause the video to check your work. How did you do? And that is how you solve an equation and justify the property for each step.